Good morning to all of you. Welcome to the webinar Enabling Digital Transformation and Testing of Legacy Substation and Devices. Myself, Sterin, and we also have Larry Price. And to start with the company introduction, Kalkitech was established in 1998 and ASE was established in 1988. So we merged sometime back in 2012. And Kalkitech primarily focus on developing and delivering vendor-agnostic products and services that securely bridges the gap between legacy and existing standards compliant systems for utilities and electric power systems. Applied Systems Engineering, or ASE, is a smart grid protocol technology leader and a leading manufacturer of remote terminal unit or intelligent electronic device protocol test equipment for the supervisory control and data acquisition industry. So during this presentation, we will cover how Kalkitech and ASE products will help in enabling the transformation of old legacy systems to new digital systems. Myself, Sterin Jose, I am working at our Campbell office. My background is on protocol side, and I have expertise on 650 protocols, DNP3 protocols, ICCP protocols, etc. And we also have Larry Price, who has 28 years of industrial communication and networking experience across electric, gas, water, and wastewater utilities. He also has expertise in AMI, AMR, DA, and EMS applications. He is doing roles like field engineer, system engineer, project management, and sales engineer. So Larry, I'm handing the presentation over to you.
Good morning and thank you. Today's agenda, we're going to talk about some of the legacy systems that are presently deployed worldwide, the new digital solutions that have evolved to transform some of the topology and communications for SCADA. We're going to talk about some of the SPT and Sync series products, solutions, and use case examples. And then we're also going to talk about testing of legacy and standard protocols using our ASE2000 protocol test set and ASE61850 test set. Today's legacy technologies vary across environments, but your standard legacy system architecture looks as follows. And when I say legacy, I mean older or somewhat dated standard protocol. So here we have an HMI and a hardwired network where everything is physically networked together. You have a control center. HMI can directly request specific data points, or the control center can issue a request for this information from the devices in the field, such as relays or RTUs, and it can also issue a control operation to those devices using bit protocols. And some of these networks exhibit certain challenges and issues to date. Some of those challenges include scalability, which is limited due to hardware dependencies, sustainability of the older hardware, slower data rates, and then complications from leaf lines and other operational expenses that are incurred to transfer this information or data from those outstation devices to a centralized control center where the data is stored and analyzed. We also have serial communications in these legacy networks using byte protocols. Both these bit and byte protocols are on dedicated networks and they have dedicated masters monitoring using required hardware and signaling parameters to meet those protocol requirements. In the newer environments today, you'll see a couple of prevalent protocols that are in use. The DMP3 protocol, which is widely used in North America, Central and South America, or otherwise in the US, as well as the IEC61850 protocol, which is widely adopted in Europe, Asia, and elsewhere. And these protocols utilize current standards and features that are synonymous with IP networks. With these networks, you can retrieve, depending on the environment, be it 61850, which differs from DMP3, you're retrieving field values and information back from RTUs across communication segments. And the benefit of both of these protocols is ultimately that they bring about interoperability between devices deployed in the field, both new and old. They allow for a path forward. Let's talk about our hardware to bit protocol use case here. In this scenario, we have a hardwired network solution which has a dedicated I/O port for a interface which is retrieving, collecting information, and sending that to the control center. And there is a need for a bit protocol to be communicated upstream across existing communication segments. And that's where we fit in because we provide support for legacy and standard protocols across our products, including but not limited to Conitel, CDC, Harris, etc., to name a few. Our other use case is converting from legacy bit to current byte protocols. Here we have a similar scenario where we have a Conitel CDC input to an RTU deployed in the field or substation. The need is for serial communications with byte protocols. We presently have hardware that's only capable of bit level protocols. Well, we provide that translation. We have an extensive protocol library. Our solutions can convert between bit and byte protocol format. And here we show Conitel data from the field being converted into DMP3 byte stream data. Another solution that we provide with our product offering is media conversion. We can convert serial data to TCP IP data format and modernize the communications between the control center and the field. Our solutions have a mix of packet counters and diagnostic counters available for traffic analysis. This simplifies asset management ultimately because you'll have one device that can operate as multiple masters with our given solution. And here we have DMP3 or serial Modbus information from the field mapped to the DMP3 LAN-WAN equivalent or IP equivalent or 61850. Regardless of the protocol, we can map from one library to another to give you the data point in the format that you seek. The SPTSRV comes in 3 different options. We have a 4-port option up on top. We have the 8-channel option in the middle and a 16-channel option on the bottom. We support both bit and byte protocols, as I stated. Some of them to be named are Conitel, CDC, TRW. We also support DMP3, IEC, Modbus. We support both serial and IP-based communications, bit-to-byte conversion, as well as serial to Ethernet or vice versa. We also support master-to-master communications, have flexibility with our power supply options, and ultimately have stability via our Windows and Linux firmware support. And one key advantage that makes our product stand out above our competition here is not only are we providing the media conversion from serial to Ethernet, but we're providing protocol translation services. That's our key differentiator. Many can convert between serial and Ethernet, but they cannot convert between protocols. So if you have a need to convert from serial to TCP or IP, bit to byte, legacy to DMP3 protocol, Modbus and IEC 101, 104, or any mix or match, our solutions can bridge the gap. Both our SPT and Sync series have a variety of applications where we fill a niche. That niche is not at the endpoint. That niche is not to be at the head end. It's in between, and it's providing protocol translation, multi-drop support, serial support, and advanced diagnostics for both networking and protocol analysis. Our Sync series product supports DMP3, Modbus, IEC 61850, ICCP, and a variety of other protocols. Across all of our product lines, we support close to 100, if not more, protocols. The Sync has terminal server functionality to convert between serial and Ethernet communications. And it also has advanced logging and database for debug and analysis internal. The device is NERC-CIP compliant and has secured access features. Here we have our Sync 200 series. This is an OEM solution for embedding in wider or larger systems, communication solutions where customers don't necessarily have the development expertise to create a protocol library. We also have the Sync 2000 terminal server series. We have a 2100 series with some I/O, as well as flexibility between Ethernet and serial communication port options. And then above that, we have the Sync 3000 robust substation data concentrator. This is a higher end gateway. As I stated before, there's a database, there's channel diagnostics, there's advanced debug features that you can capitalize off with this device for both commissioning, deployment, and just standard monitoring. And then to tie it all together, we have our Sync Connect software solution, which allows for intercommunication between all of our solutions and consolidates all that information to a central area for additional development, product feature enhancement, et cetera, from on the head end. You have the ability to support third-party applications, do some custom development, et cetera. And here's our Calki.io cloud platform. This is where we can bring all of this information back from any of our Sync products into a cloud-based platform. As I said, there's API support, there's third-party app support, and custom development support. When it comes to testing of legacy and standard devices, we have a couple of protocol test set solutions. The ASE2000 test set supports presently over 40 different protocols. Serial communications are supported, both bit and byte, as well as TCP, IP communications or Ethernet communications using DMP3, Modbus, to name some of the common ones, IEC 104. And with our test set, you can simulate master communications and test outbound requests and evaluate the responses. You can also emulate or simulate an RTU or field device and scan for responses and requests that come downstream and actually generate those responses back. You can perform point simulation real time, as well as you can toggle values to create event or change conditions. And we also support file capture of communication sequences between masters and outstations for debug and analysis between engineers and technicians. You can interchange files readily and share those for troubleshooting purposes. Master simulation, RTU simulation, and monitoring. When it comes to monitoring, there's a couple of different means of monitoring. You can monitor live, passively serial communications, or via a IP mirrored port, you can actually capture live two-way Ethernet traffic between your control center, master station, and RTU. Some of the highlights of the ASE2000 test set: the master outstation role, RTU simulation role, monitoring. Messages are displayed. They show the raw units or raw data as it comes in from the destination or outstation device. We have point logging. You can define conditions and parameters to write to a log file when a point changes, as well as record timestamp. We also have some signal measurement capability on the RS-232 side for fine-tuning serial bus. And in addition to that, we have a free message viewer, so our unlicensed users out there can download the application, take a look at a file shared from one of our licensed users, and be able to review the information and assist them as needed. The use case for that would be an RTU manufacturer possibly working with one of our customers trying to resolve a functional issue with a newly deployed device. All of the communications will be visible to that third party. So we have a few different modes of operation. We have a task mode in the test set, which is a predefined list of standard SCADA communications, such as data scans, exception scans for both binary and analog information. It doesn't take an expert or anyone with SCADA expertise to be able to define the parameters and initiate basic communication testing using task mode. And then with RTU simulation, we can toggle points, increment analogs, and totally simulate a realistic RTU or IO type environment. And then we also have monitoring using our beacon, which has the accuracy of up to 100 milliseconds for measuring transmit and receive gaps between the master station and the RTU. So as I said, we can fine tune or allow you to fine tune those RS-232 and 485 buses used out in the field. And with our traffic monitoring below, we have a nice a window view, which can be user defined. You have some different means of flagging information, both audibly and visually as it's received. I encourage you to take a look at our website for additional information on that. Today's webinar is not to go into depth on the ASE2000, but merely highlight some of the features. There's a lot more material to cover. And with that, I will hand this off to Mr. Stern Jose.
Yeah, thanks, Larry, for explaining the details of SPT, Sync, and ASE2000 products. So now we will start with the ASE6150 side of it. So what you see currently is the functionality of a typical 6150 protocol, where you have merging unit functionality on the left-hand side. The merging units will be typically connected to the current transformers and voltage transformers. And further, the data will flow towards the relays, protection relays, and other devices through process bus communication. And further, there will be kind of functionality of protection relays sending data back to the bay controllers to trip the breakers, and the devices will also share the data to HMIs through MMS protocols. So this is the typical architectural diagram of a typical 6150 substation. So here we have several options to test. So one functionality we offer is the functionality to test the process bus. When the information is sent out from the merging units, there will be a requirement to capture that information and analyze that information. So we have our ID Smart, which is a 6150 server function. That specific tool will allow you to capture sample values and also convert these sample values to comprehend files for detailed analysis. So that will allow you to debug and troubleshoot the merging unit related issues in detail. And on the bottom, you can also see that the 6150 server simulator is capable of acting like an IED. As you know, IEDs will have their ICD files or SCL files. The ID Smart tool can take input of an SCL file of a specific relay and act like a real relay. There are several simulation features available to simulate the device. The simulation includes the Goose simulation as well as report simulation. So if you have a requirement of testing an IED, you could do that using the 6150 server simulation functions. And on the right-hand side, we have a client tool which supports features like capturing the Goose messages, capturing the data through reports, and it will also highlight the changes as you see in the diagram. As soon as the data is collected, it will highlight the changed values, and users can notice it very easily. So it has got several other features to enable reports, Goose, also monitor the data exchanges between IEDs. And on 6150 side, the detailed features include the discovery of IEDs. If you feed the IP address, it will discover the device configuration and provide everything for you. And the server functionality or server tool will be able to simulate the devices using their SCL files. Client tool can collect the data via poll, report, and Goose. And server simulator will be able to simulate the reports and Goose in the network. The main functionality of client is the capability to highlight the changes as soon as it is available in the machine. So user interface will allow user to see the changed data very easily. We also keep the history of point changes, Goose collected into the system, and also the reports. So at any point of time, we can go back and see what happened over a period of time. And main capability of server simulator is to simulate multiple IEDs. So we can virtually simulate a substation with multiple IEDs on a PC. So we also have the capability to publish and subscribe Goose messages in server. And in server simulator, we have the capability to simulate data with millisecond accuracy. We can flush out multiple events and generate a lot of events, which could also create something like a flood of events. So these capabilities are available in our server tool. And recently, we have added the sampled value simulation the sample value capture and conversion to ComTrade. These features are added recently into our server simulator. And our client will have a new feature called Goose Workflow. It will allow you to monitor the Goose transactions very easily. So this is the typical view of client tool. There will be a tree view of IEDs on the left-hand side of the tool, and further there will be an option to highlight the recent changes, whether it is data change or report arrival or Goose collection. There will also be a history of updates. It could be for reports, Goose, and data point changes. And in server side, we have manual and automatic simulation. Automatic simulation has got multiple modes, and one of which is very simple, using comma separated values, and other is through scripting. And here in the server, we have the capability to simulate Goose, report, and sampled values. And we can also capture and analyze the sampled value using a ComTrade viewer. So these are some of the features provided for 61850 based systems. I think that's all for today. I think we quickly covered the SPT devices, sync devices, which are protocol translators, and we also discussed about ASE2000 and ASE61850, which are testing tools for these systems. We have a few questions right now. So Larry, I will read out some of the questions. So first one is on the power supply. So the range of power supply that we support in SPT and sync devices. So do you want to answer that?
Yes, we have flexibility, both AC and DC. We have a wide-ranging AC power supply that are universal power supply for both North American and European inputs, as well as 12 volt we have 12 volt support, 5 volt support. 1 second, let me actually bring up all those options. There's more options than I know off the top of my head. Apologize for that. 1 second. Let you know the answer off the top of your head.
So we have one more question. Yeah.
And the next question, thank you. While I'm bringing that up, go ahead. What's the next question?
Larry, we have one question on 61850. So while you pull up the data on power supply, I will answer the question on ASE61850 side. So the question was on the Goose workflow monitoring. So one participant has asked what exactly is Goose workflow. So so Goose workflow function is basically to monitor a set of input and output values of a IED. So functionality we are trying to offer is the input into an IED and output from the IED in the form of Goose can be added to a pane. This pair of values will be monitored by ASE61850 tool, and it will tell you whether the output value changes based on the input Goose. So it will be a handy feature to find out whether the devices are acting based on the Goose inputs and the timely actions are generated. So we are introducing this feature in our next release of ASE61850 client, which would happen somewhere in October. So Larry, do you want to answer the other questions on SPT? We have a couple more questions on SPT. Shall we go with that? Yeah. I think Larry is trying to pull the information.
Can you hear me?
Yeah, I can hear you.
I have my phone muted. Yeah, the next question, please.
Yeah, the next question is on the multiple channel support listed for SPT. How does this relate to master outstations? So that is the next question.
So each channel with our offering, be it 4, 8, or 16, can operate as an individual master. So in the case of an SPT4, you can have a DMP3, it's a 4-port channel solution. You could have a Modbus master, a DMP3 master, an IEC104 master, and a CDC master, for example, and they operate independently.
Okay. So the next question, yeah, is it was on the same line where one user has asked whether these channels can operate independently. So I think you already gave that answer, right?
Yes.
Yeah. Okay. So yeah, so these channels can operate independently. That is the answer to the next question. I think we covered most of the webinar topics for today. And if you have any additional questions, please write to us through our support contact, or if you have any other modes of communication, you can also use the telephone to clarify your doubts. We will be happy to assist you. So with this, we are concluding our today's webinar session, and thanks to all for attending. Bye.
Thank you very much.
Yeah, thank you. Bye.